All right, so this is the last lesson in this week's unit, whatever. You get me. It's the last lesson, and then we'll have a test. So yesterday we talked about what makes things binomial, and today we're going to talk about actually finding the probability for that binomial. And the most amazing thing ever is that Desmos does it all for you. Okay, so first we're going to talk about it. Of course, we know there's this huge long formula, but we know that Desmos now does it for us, so we don't need to know this formula. But I would like you to know what the variables mean. Okay, so n means the number of trials. Remember when we were talking about it being binomial, we have to know how many trials we're doing? That's because it's part of the formula, okay? So I need to know how many times I'm doing this probability, okay? P is your probability of success. That means what's the probability that you get what you want, okay? And you have to be careful with that because sometimes the questions will say this is the probability that a glass will break, but you're looking for the probability that the glass won't break, so you'll have to subtract it from 1, okay? Because all probability adds up to 1. We've talked about that, okay? X is the number of successes. X is how many times do you want to get what it's asking for, okay? You're doing 6 trials, but out of those 6 trials, how many times do you want to win, okay? So this is your formula, all right? We're not going to be doing much with this formula, okay, because like I said, Desmos does it for you now, okay? So let's go ahead and go to this example. So I want to show you that it is binomial, even though you know this is about binomial probability, so I'm giving you examples that you can calculate, okay? So is this binomial? So it says if I roll three dice, what is the probability of only one of them being a 4? So is it binomial? Is there 2 outcomes? Well, I want to roll a 4, so I'm either going to roll a 4 or I'm not going to roll a 4. So yes, it's 2 outcomes. Is it an independent event? We've talked about rolling dice is an independent event. Fixed number of trials. Do I know how many I have? Yeah, I've got 3 dice. So that's right. And is it the same probability? Well, if it's independent, then it is the same probability. So this is a binomial experiment or probability, okay? So now I want to actually do this. Now, this is how you could do the formula, okay? This is showing you what the formula gives you, okay? So I should get an answer of 0.347. Now we got to put in percent form because we're doing probability. There's a 37.42% chance that I only roll 1 of the dice and it's a 4. So I'm going to roll 3 dice at a time and I have a 37% chance of one of those dice being a 4. Okay, so these are the variables you need to know right here, N, P, and X, okay? You have to know those so you can put them into Desmos, okay? N is the number of trials. Well, we're talking about rolling 3 dice, so that's where the 3 comes from. Probability of success. You do need to know how to find the probability. Well, a 4, how many 4s are on a dice? 1. Out of how many total numbers are on a dice? 6. So that's where the 1 6 come from. Number of successes. How many of those dice do I want them to be a 4? Well, I only want 1 to be a 4. That's where the 1 comes from. So my N is 3, my P is 1 6, and my X is 1. Okay? So we're going to go to Desmos, and I'm going to show you how to calculate this in Desmos. Okay? All right. So let me get it pulled up. Here we go. All right, so let's go to Desmos. All right, so we're going to go down here to the keyboard. You need to go to functions. We're in the stats unit. Well, sorry, not stats. It's this one. It's the distance one. We want the binomial one right here. Binomial, okay? What you type in is you want to type in your N and your P, okay? So I'm going to type in a 3, comma, whatever your P is that a comma? No, that's not a comma. Your comma's right there. Sorry. And then you want to write in your probability, which is 1 6. Okay? Close the parentheses. See how it says find cumulative probability? Do you remember that if you look at the formula, what's there? NCX. Guess what? That is what this is. See how it says CDF? That's what we want. Now, you've got to have a min and a max. Okay, well, what is my number of successes? My number of successes was just 1. That's it. So my min is going to be 1 and my max is going to be 1 because I only want 1. okay? So I'm going to put, I want 1, and I want my max to also be 1. And looky there, is that not the same thing that the formula gave us? It is. So that's all you have to do, and that's your answer. And so what I would do is, so you see how, let me get this pulled up. All right, let's trash that. All right, so you see how, let's go here. Okay, oh, no, let's see, go away. Completely off alignment, whatever. All right, so this is what it is. I've got 0.3472, okay? To change a decimal to a percent, you take this decimal point and you move it 2 places to the right. So that's where the 34.72% comes from, okay? All right, let's do another one. So we're here. All right. So you also can use your calculator, but Desmos is even simpler than the calculator. So you have the formula, which is it's not hard, but you have the formula. Then you have the calculator that'll do it for you. But Desmos is the absolute easiest one, in my opinion. All right, so here's another one. It says, a company that produces fine crystal knows from experience that 10% of its goblets have cosmetic flaws. 6 goblets will be randomly selected. Okay, so N is your go back here, sorry, your number of trials. P is your probability of success, and X is your number of successes. Okay, so I have 6 goblets that I'm randomly selecting. Okay, that's where the N comes from. All right, now there's a 10% chance that goblets have flaws. Now you got to change that 10% to a decimal. So you take this decimal and you move it 1, 2 places to the left. That's where the 0.10. And X is going to be how many flawed goblets there are. So let's go to example 3. I want to know how likely is it that only 1 of them is flawed. Just 1. So I have 6 goblets that I'm testing. There's a 10% chance that they're flawed. And then I want 1 flawed. Okay, so we're going to go back to Desmos. Okay, we're going to do this again. Let's get rid of that. We're going to do this again. Pull up your functions, binomial. I have 6 total goblets, a 10% chance that they're flawed. I want to find that probability, so I'm going to click. I only want 1 to be flawed, so my minimum is 1 flawed and my max is 1 flawed. And there's my answer, 0.354. Round that 2 to a 3 because of that 9, so 3543. So 0.3543. Move this decimal 1, 2 places, and I've got a 35.43% chance that 1 goblet is flawed. Okay? All right. Let's do it. I want to know how likely that at most 2 are flawed. All right, when I say at most, so if I say you can retest at most 2 times. That means you can't retest more than 2 times, right? So you can retest 0 times, you can retest 1 time, or you could retest 2 times. That is what at most means, okay? So that means I want to do 0, 1, or 2. Now, calculator makes it harder, but Desmos does not. So I'm using the same problem. So my N is still the same and my P is still the same because I haven't switched problems. But what I want, this is what I want, it has changed. I want 0 to 2 goblets flawed. So that's where we play with the min and max. I want minimum of 0 goblets flawed to a max of 2 goblets flawed. And there's your answer. You have a 0.98415 chance. That 5's going to round that 1 up. So when I do this, so right now I have 0.98415. Okay, we want 4 decimal places, so that 5 rounds that 1 to a 2. So now I have 0.9842. Move that decimal 1, 2. I have a 98.42% chance to get 0 to 2 goblets flawed. Okay? All right, let's keep going. Next one, same problem. We're still talking about goblets. So my N is still 6. My P is still 0.10, but my X will change. I want to know, find the probability that I could have 2 to 4 goblets flawed, and see how it equals. So that means I want 2, 3, and 4. So that means my min is going to be 2 and my max is going to be 4. Okay, so I go back to my Desmos and I'm going to play around with that min and max. And I'm going to delete that, exit that. Oh, Mufasa. There we go. So I want between 2, right? Wasn't it 2 to 4? Yeah, 2 to 4. So we're going to backspace 2 to 4. So I have so nothing rounds. That 1 does not round that 2. So I've got 0.1142. Change it to a percent. There's 11.42% chance that I have 2, 3, or 4 goblets flawed. Okay? All right, so example 4. It says Willy Wonka has hidden golden tickets in his chocolate bar. He says there's a 5% chance of one candy bar being a winner. If Charlie purchases 5 bars, what are his chances that at least one is a winner? Okay, so we need our N, P, and X. N, how many total candy bars does he have? So N's like your total of whatever you're talking about. So he purchased a total of 5 bars. Now pay attention to what the question is asking, because it could say what's the probability of it being a loser, and you would have to find the opposite percent, okay? But it does say he wants to be a winner, 5% chance. Well, you have to change that to a decimal. Remember the decimal's right there, and you have to move it 2 places to the left. So my P is 0.05. X. Now it says at least one is a winner. So when he says at least is going to mean that's the minimum. So he wants a minimum of 1 winner. So he wants a minimum of 1 winner. That means he doesn't care as long as he at least 1 wins. He doesn't care if he wins 5. He just wants at least to be one of them to win. So it's going to be from 1 to 5. So at least means that's your lowest number, and then your N is your max. Okay? So that's going to be my min and my max when I go to Desmos. Okay? All right. So let's go to Desmos. Pull it up. And so we're going to do a new one. So I'm going to get the binomial distribution. Okay? So we have a total of 5 bars. There's a 0.05 chance of winning. Oops, I didn't put the 0.5. 0.5. And then I want to turn on the probability calculation. And I want a minimum of 1 to win, but I don't care if all 5 win. So my answer here is going to be 0.2262. So 0.2262. So 0.2262. Move that decimal 1, 2. So there's a 22.62% chance that he will win. Okay? All right, last one. Okay, so Abby took an 8-question multiple choice quiz. Okay, 8-question multiple choice. Suppose that the probability of correctly answering is 0.75. What is Abby's probability of incorrectly answering 2 questions? Okay, so this is where you really need to pay attention. Okay, it said what's the probability of incorrectly answering her quiz. Okay, so it gives me the probability of correctly answering. All right, so let's write this out. Let's see what I'm talking about. Okay, so we need our N, P, and X. So my N, 8 questions total. Okay, she has a 0.75% chance of correctly answering. Okay, but I want to know exactly 2 incorrect. So I want 2 incorrect. So this is correct. So we have to say 1 minus the 0.75 to get the opposite, which is 0.25. Okay? If you ever want the opposite, just subtract what they give you from 1. So when I go here, I want exactly 2. So the 2 is my min and my max. Okay? So we go to Desmos. And we're going to do another one. So functions, distribution. So I have 8 questions. There is a 0.25 chance of incorrectly answering. I want to find that probability of 2 to 2. So that's my answer. 0.311. That 6 is going to turn that 4 into a 5. So it's 0.3115. Move that decimal 2 places. So I have a 31.15% chance of incorrectly answering that multiple choice question. Okay, guys? So that's it for today. You will have a review on Monday and a test on Tuesday.